So we are taking a look at section 2.2 goal 3. We did not have time to go over this goal in class today, so I wanted to touch base on it with you right now. So thanks for tuning in. Goal 3 says find min and max values of quadratic functions in real-life applications. At this point, I want you to take out your graphing calculator, and I'm going to allow you to use it to solve for your real-life applications. So let's take a look at this problem. A baseball is hit at a point 3 feet above the ground with a velocity of 100 feet per second and at an angle of 45 degrees with respect to the ground. The path of the baseball is given by the function f of x equals negative 0.0032x squared plus x plus 3, where f of x is the height of the baseball in feet and x is the horizontal distance from home plate in feet. What is the maximum height reached by the ball? I know that's a lot of information, so the first thing I want you to do is circle or underline or highlight what you're being asked to solve for. It asks for the maximum height reached by the ball. So the next thing I want us to do is analyze the function that is representing the path of the baseball. This function I see has a degree 2, which tells me it's a quadratic. I also know the leading coefficient is negative, which tells me this is a parabola that opens downward. So I know that I have a parabola that opens down. That's a terrible parabola. Sorry, I'm trying to freehand this on my computer mouse. Let's look some more. It asks, what is the maximum height reached by the baseball? Well, if this is the path of the baseball, think about where would the maximum height occur? And if you said that the maximum height would occur at the vertex, you would be correct. Okay, so let's back up a little bit more. It said that the baseball is hit at a point 3 feet above the ground. Well, so the ground, if we were to put this on a coordinate plane, the ground would be represented by the x-axis. Let's continue reading. When the ball is hit 3 feet above the ground, its horizontal distance from home plate would be 0. So home plate would be represented by where the x-axis and the y-axis intersect. So we have home plate here. This point is 3 feet above the ground. That's where the bat hits the ball. And so this is the pathway that the ball takes until it comes back and hits the ground again. So that's our thought process I want us to go through. So if it asks for the maximum height, I know that I'm at the vertex. I know that every vertex has an x coordinate and it has a y coordinate. So you know that this is going to have 2 values. So you've got to decide, is the maximum height the x coordinate or is it the y coordinate? If we go back to the explanation about our function, it says that f of x is the height of the baseball. We know that based on functional notation, f of x is equal to y. So if f of x is the height, then y is also my height. So we will be looking for the y coordinate of the vertex. So let's talk about how do I graph this in my calculator and let my calculator do the work to find that. On your calculator, if you are on the home screen, you can simply select the picture of a graph, or you can tab down to that. You can move your arrow keys until you get to that and press enter. Also, if you are on a screen, you can select Control plus page or control doc. You can tell it to add a graph. In this bar where you see the blinking cursor, you will enter your equation. Anytime you're entering an equation, make sure that you use the variable x. Even if the textbook uses a different variable, if you are graphing an equation, you must use an x. Now you may be thinking, that does not look like a parabola. That almost looks like a linear function. Well, remember, it's important to zoom out so that we can see more of the parabola. To zoom, you will go to Menu, Window Zoom, Zoom Out. And once you have the magnifying glass, continue to move it and press Enter until you can see the bulk of your parabola. Once you have the parabola on the screen where you would like it, press Escape. And I'm going to drag this equation out of the way. So here is the parabola, similar to what I drew. And remember, we want to find the y-coordinate of the vertex. There are two ways to find the vertex. I'll show you both. You could select Menu, Analyze Graph. Because our vertex is a maximum, we would select maximum. If our vertex was a minimum, we would select minimum. And I have this finger that's attached to that vertical dashed line. And the first thing I want to do is pull it to the left side of the vertex and then press Enter. And then pull it all the way until the word maximum, or till I'm to the right of my vertex, and press Enter again. And you can see that we have a vertex whose ordered pair is 156. And I think that says 81.1. So again, you have to decide, is your maximum height 156 feet or 81.1 feet? We've already determined that height is our y-coordinate. So our maximum height is 81.1 feet. What is this 156 feet all about? The x-coordinate of 156 feet, well, as we were reading in the problem, x was represented as the horizontal distance from home plate. So that means that when the ball is 81.1 feet above the ground, it's also horizontally 156 feet from home plate. Let's look at this second question. It asks, how far away from home plate does the ball land? Okay, I want you to put, draw an arrow to, or draw a circle, or X marks the spot on your paper, on the picture that you drew, showing where the ball lands. Remember, we said the x-axis is the ground. So I believe that the ball is going to land right here. And that point is an x-intercept. Now we know we have two x-intercepts. This x-intercept on the left is behind home plate. So we know logically that the ball, if the ball is following this pathway, it's going to land the second x-intercept. So how do you find that second x-intercept? I'm going to show you a second way to find points on your calculator. Remember, I told you I would show you two methods. So rather than analyze graph, this time we will go to trace, graph trace. And I'll move my arrow keys to the right or left. Since I need to go to the right-hand x-intercept, I'll continue to scroll to the right until I get to that x-intercept. And it pops up and tells me that I'm at the 0. You saw the word 0 pop up. Now you may be wondering, why does my ordered pair not 315, 0? If you will press the up arrow, the calculator will adjust for you and change that to 0. Just sometimes doesn't land right in the perfect spot. So we land 315 feet from home plate. So this is the rightmost x-intercept, which is 315 feet. So on any of the application problems on your homework, please feel free to graph them and answer the questions by using your calculator. I much prefer you to do that. Thank you.